All right, so the first thing to say about meanders is that they become more accentuated over time, which means they become larger. So we see here, this is almost a bit of a timeline for a meander. So we start to see that the bend is actually a small kink, right? It doesn't actually do much. It's not too accentuated. But due to erosion and deposition, which we're going to talk about in a second, the meander becomes larger and larger, okay? And what actually happens, and we'll talk about this in the end, is this becomes a bit of a cycle, okay? So basically they become more and more accentuated due to erosion and deposition, and then it kind of collapses and the whole process starts again, okay? So that's something to know, and we'll come back to it in the video, but let's get into the nitty-gritty of the actual process. All right, so let's talk about meanders. We know they accentuate and get larger over time. They're also found in the middle course of rivers. So in an exam, it may ask you to explain the formation of one landform found in the middle course of a river. This would be the one that 90% of kids would be writing about, would be meanders. All right? It's a geographical physical process, so your key terminology is absolutely essential. But it tends to be pretty all right. Kids don't struggle with this too much. So we're just going to draw our direction of flow as such, okay? A river is flowing from east to west, okay? So as it flows, it's full of kinetic energy. Yeah. Now, these are how kind of small bends develop and get larger is through erosion. Erosion is taking place on the outer banks, okay? So erosion is taking place here, here, here in this diagram, okay? Now this is the key bit. Well, why is that? It's because the flow of the water, and I should really be saying the velocity of the water, is fastest on the outside. So it's faster on the outside of the bends than it is on the inside. And so we're going to experience water smashing into the side of the rock. So that's going to cause hydraulic action. So what we see is erosion, hydraulic action, but also some abrasion taking place to erode this way and to erode this way, okay? Now, because it's fastest on the outside of the bend, you're seeing erosion. But the opposite is taking place on the inside of the bend. It's going very, very slowly. And we should know from our unit on coasts that when our water loses energy, all that sediment it's transporting starts to be deposited, okay? So that's another key thing that you have to know. On the inside of a meander, you are going to see deposition, whilst on the outside bend of the meander, you're going to see erosion. Okay, so it's going to grow this way, and it's going to grow this way because deposition is also taking place on this inside bend and this inside bend. So you need to get your head around the idea that the water is going fastest, it has the highest velocity on the outside, and what means on the inside it has the slowest. I often used to talk about like if you look at Formula 1 cars going around a corner, they take the longest route to go around. They actually take the outside bend because they can carry that velocity. The same kind of thinking is going on here. So, how does this actually develop? What's actually going to happen is, we call this the meander neck. And again, to use another metaphor, it's about to get decapitated, okay? Because erosion continues to take effect. The meander neck gets thinner and thinner and thinner and thinner, And eventually what happens is that during a flood or over a long period of time, the water will break through here, okay? As the meander neck gets narrower and narrower and narrower, eventually it breaks through. So, what's gonna happen? I have to do some rubbing out here. It's gonna be a bit messy. Yep. The meander neck has got smaller and smaller, and eventually erosion still takes place. It breaks through, hydraulic action, abrasion is still taking place. It breaks through, and now the river has another path to take. Now remember, rivers are lazy and slow. They take the path of least resistance. So now water is going to start going this way, all right? And less water is going to go this way. And the water does go will be much slower. Slow water, water with a low velocity, does deposition. And eventually, this gets cut off. New land is created. And now we have what we call an oxbow lake. Okay? The land now forms like this. So there's no water coming in, there's no water coming out. It's called an oxbow lake. So there is no flow. Eventually, the oxbow lake will dry out and it will form an oxbow scar, okay? And the meander process will start all over again. This oxbow scar will be left behind. The river is now a lot straighter than it once was. And then this meander that you now see will start to form another meander through erosion and deposition. So this is found in the middle course of rivers. It's a process that requires you to understand velocity on the outside versus the inside. On the outside we have erosion, hydraulic action and abrasion. On the inside we have deposition. Yeah, and then it's a cycle, so it kind of, as soon as it's over, it starts again. And that's the formation of a meander and an oxbow lake. Okay, so let's tackle a question from the AQA 2020, paper 1. If you're doing edit cell A or B, it still should be relevant because it's an exam question and it's a physical process, so they're going to be very, very similar anyways. So here is the question. Again, if you know how to bug the question, I would encourage you to pause the video and bug it now. But yeah, if not, I will continue and I'll show you how I would do it. So bug, box the command word, explain. You, underline the keywords, meander, formed, erosion, deposition, and then glance at the marks, 4 marks. Use one or more diagrams to solve the answer, so that suggests we do need a diagram. But in many of the other courses, we don't need a diagram. So here is our mark scheme. Again, there's a lot there. 90% of that we covered in the video. So if you pause it and have a little quick read, you'll see it's kind of all there. We've got kind of curved bend, fastest flow, erosion, deposition, shallower areas, and so on. Okay, have a read and see if there's anything that you need to revise. If not, we will continue. This is a kind of diagram that was included in the mark scheme. So if you take a second again, pause the video and have a look. There's not really much that we didn't cover here. So it's deposition on the inside bend due to slower flow, erosion on the outside bend. We can say lateral erosion, meaning kind of the opposite of horizontal. And then what we see is the meander neck thinning over time and so on. So again, they're not asking you for a huge much with the diagram. I think everybody would be pretty confident producing something similar to that. We're going to proceed as if you didn't use the diagram and just went for the 4 marks using just your written words. So here here is our structure. As always, one blank is, I would say, one cause is. Because, here's again, we kind of start to develop it a little bit further. This means that, and as a result, so we're going to get 1 mark for the point, a mark for because, a mark for this means that, and a mark for as a result. So, let's dive into a model answer that I've prepped already. So, one reason is the differing velocity found within the river. AKA, we're talking about fastest flow on the outside, slowest flow on the inside. Because water flows faster on the outer bend of a river, causing erosion, whilst it flows slower on the inner bend, leading to deposition. Again, I'm just to put into words what that diagram was already showing us. This means that eventually an oxbow lake will be formed as the meander neck is cut off. You could change cut off with eroded, but cut off works for me, okay? So again, I'm talking about that process, oxbow lake being formed, meander neck being cut off. As a result, the river develops a curved, meandering path over time as the cycle repeats itself. So I link it back to the idea this is a cycle of rivers bending and straightening and bending and straightening as they go. Okay? So that is again another classic answer. You combine your point, differing velocities, with your connectives, and you use that key geographical language like erosion, deposition, oxbow lake, meander neck, cycle. You know, use that type of language. You combine it with connectives, and you're going to do very, very well. Okay? So I believe that gets 100%. I hope you found this useful. Like and subscribe as always for future videos. And yeah, good luck, and I'll speak to you soon.